This is Chapter 3, Assembling and Testing the Boe-Bot. So first is assembling the Boe-Bot robot. The tools are shown here that you have your parallax screwdriver that comes with the kit. If you have them, a 1/4 inch combination wrench and needle nose pliers. In the topside hardware, what you need is the chassis, which is the metal here. Mine is slightly different colors than the ones shown in the picture, but the same thing. The 1 inch standoffs, which are the metal cylinder poles, and then the panhead screws, which are the smaller screws, and there should be 4 of them, and then a rubber grommet. So what you're going to do is you're going to take your rubber grommet and you're going to put it inside the hole on the center of the Boe-Bot chassis. So you just kind of push that in there. And there you go. So make sure that everything's nice and round on both sides. Okay, and then what you're going to do is attach these standoffs to the spots as shown in the picture using the 1/4 inch screws. Okay. Now, for me, I like to put the screws in first. And then I like to hold it with the screwdriver. And then screw on the standoffs. And I think that's a little bit easier. And then you can tighten it using the screwdriver if you need to. Okay, so do that 3 more times. So if you still have your board connected to the LEDs and the servos and everything, go ahead and disconnect everything from the board completely, including the battery. And you should see the servos now disconnected. And what you need to do first is take the servos and go ahead and take this screw out. Don't lose the screw, you need it. But you need to take it off for now because the control horn is not being used in this part right here. And you just kind of pull off the horn. Might be a little tough, but it should come off pretty well. Then go ahead and do it for the other one. Okay, just like that. So what you're going to do is put the servos on the chassis on the inside. So, um, previously I have put a piece of tape. They say use masking tape, but you can use any tape you want. And put an L and an R on each of the servos. So you know which one's on the left side and which one's on the right. Okay. And then you also need 8 of the nuts and the slightly longer screws. Okay. So the right, if you face this part of the chassis away from you, okay, then the right is then on the right. So take your right servo, put it in, and make sure that your wires are through first. And then there are 4 holes, one where each of the servo lines up with the holes on the chassis. And you go ahead and install the nuts and the screws. Now, this is where it can get a little frustrating if you don't have the 1/4 inch um, wrench or a pair of pliers. Either one of these should work well, but what you do is you go ahead and put the screw in, and then on the other side is where the nut is going to go on the screw right here. Okay. So again, it's not super necessary, but it is a good idea to have a wrench here or the pliers. So what I like to do is kind of get it started if you can. Might be a little tricky. Just a little bit. And then you can hold the nut with the wrench and then use the screwdriver to screw in the nut or the screw into the nut. So I'm going to set this down. Okay. And there you go. So you do that 4 more times, or 4 times total on each servo, 1 screw on each of the holes. So I'm going to go ahead and do that now. So the servos are now attached to the chassis with all 8 screws and 8 nuts. All right, let's go ahead and continue. So if you're using the battery pack, you can mount it using the flathead Phillips screws that are attached and shown in this picture. I'm going to go ahead and just use a 9-volt battery because I think that's a little less work to do. But if you want to attach it, you can. It gets attached to the inside above the servos. Now, the one thing you do need to do is, regardless of whether you use the battery pack or not, you need to put the servo lines, the wires, through the center hole where that rubber grommet is. one at a time. Okay. Next up are the wheels. So the wheels, you need the Boe-Bot you just started making, the 1/16 inch cotter pin, which looks like this, the tail wheel ball, the rubber band tires, the wheels are blue in the picture, mine are black, the two plastic machined wheels, and two screws that were saved in the removing the servo horns step. Okay, so you can see I've gone ahead and attached one of the rubber bands to the wheels. That's what it will look like. So what you do is you take the rubber band and you just wrap it around the wheel. And just kind of adjust it so it stays. Okay, something like that. So for the ball and the cotter pin, what you do is you take your ball, where mine is black, and it has a hole, and then you take the cotter pin, and the cotter pin, all of it is going to go through the hole, both parts of it, and then also through the hole of the ball. Kind of have to push a little hard. And then push the other end of the cotter pin into the other hole, where the cotter pin serves as a axle. Might get a little stuck. There we go. So again, you can use your pliers to help you with pushing if you need to. And then it wants you to take the cotter pin on the ends and bend the ends of the cotter pin apart. Just a bit. It doesn't need to go crazy. Now you can rotate this a little, but it's going to rotate on its own. And the balls should roll more or less freely. Okay. So then what you're going to do is you're going to put the tires on the same spot where the shafts came off and put the screws back on. So there's a flat side and a not flat side. So you use the kind of pointy part, and the flat side faces out. And you just gently push that onto the servo. Okay, it doesn't go on very far. And then put the screw in and tighten it down with the screwdriver. Okay, and then the same thing on the other side. Okay. All right, so far we've got a nice Boe-Bot frame with the wheels. So I have a Board of Education, so I'm going to be following the left side here. So the board goes on top of the posts here. Now you're going to need some more of those small screws that you use to install um, the posts to the chassis. So here's what it shows at the end. And then it talks about how to put um, the wires back in the way you found them originally. Okay, so let's try this. All right. So even with those rubber feet on the bottom of the board, it fits really nicely. Okay. So then on my Board of Education, I need to put the left side in pin 13. And then my right side on pin 12. And then you can see I tucked in the wires, but they tend to come out. So what you do is you go on the other side and pull any of the excess through. So that way it doesn't come out again. And you can also tuck it under the servos if you need to. You can use a screwdriver to push it in there or something. Okay. Activity number 2, retest the servos. According to the book, the front of the Boe-Bot is actually the opposite side of the ball wheel. That means that the right side is the one facing the right of the flat side. Okay, so my ball is here, so that means my right side is here. So we're going to test the right wheel by writing a program that makes it turn clockwise for 3 seconds, stop for 1 second, and then counterclockwise again for 3 seconds. Our example program is write-servotest.bs2. So let's go ahead and put that into our Parallax IDE. Now again, you could just copy all of this, but let's try it ourselves. So as usual, we need our debug. What we learned before was if we're going to have the wheel not continuously do something, we're going to use the for and next commands. But before we use the for, we need to define our variable. So counter variable, and then again, we're not going to go past 200, so we can use the byte. So capital. So for counter equals 1, 2. Now the number we need depends on the time. So if we have 650 and 20, and then the amount of time for the next command, and then we divide that by the number of seconds that we want. So 3 seconds divided by that number of milliseconds, we get 122 as we had before. So what you can do is put a comment here, indicate where in the program we're doing this. So pulls out pin 13, or excuse me, pin 12. Pin 12 is on the right with the right label. And we're going to do 650 for the clockwise. Pause for 20 milliseconds, and then have the next. Now this time, we only want it to pause for 1 second. And so we're going to go ahead and do the 4 counter again. 1, 2. Now, how do we determine the number of counter? That is, again, the total number of time in milliseconds. So 1 divided by that. So in this case, it would be 40. And again, you can go ahead and put your comment if you want. Now we're going to continue this pulls out idea, but this time we're going to set it to the center number of 750. Then once again, we're going to have this rotate the other direction for the same amount of counter clockwise. Okay, so 4 counter equals 1 to 122 again, but this time we're going to make this 850 and then pause for 20 seconds, or excuse me, 20 milliseconds. Finish our command for the 4 next, and then we need to end the program. Okay. Save file. And download. So make sure you turn on your switch. Download. Now, again, make sure you push reset because when you did this, it's already running. Not bad. All right. So we're going to do the same thing, but this time we're going to do it for the left wheel on the other side. So I'm going to go ahead and copy what I just did, do a new file, save as, and this time we're going to do the file name left servo test. It's going to be the same programming, but this time we're going to have a different pin. So instead of 13, we're going to do, or excuse me, instead of 12, we're going to have 13. So just change up all these 12s into 13s. Save and download. Again, the program's already running. So let's go ahead and give it a few seconds to stop. And let's try it. Okay. That worked.